Okay, so that's the second problem. And this one is, they give you this name, antimony pentachloride, and you're supposed to know what that means. Okay? Antimony, what's the symbol for antimony? SB. Penta means 5, chloride means chlorine, right? You guys put this one together, and then I'm going to say, oh, that means SbCl5. And this is what compound that people would love to write. And the selenium, which is and the dichloride, I guess this is SeCl2. So you finish the first test, and then let's look at the periodic table. Okay, so we are dealing with SbCl5, and this is where antimonies are located, which is in the 5 column. So Sb means 5, and you need to make 5 bonding. So how many extra electron do you have left? You have? No, right? So there's a no electron, so no lone pairs. So okay, so then what do I do? That means number of electron group is 5. 5 means triangle, things upside down, right? So that's a trigonal bipyramidal structures. That means you got 5, and then this chlorine is located on triangle plane and axial up and down position. So that's where they're located, and antimony in the middle is located like this. And if this is another notation that most people use. What you do is, okay, let's imagine those 3 lines on the same plane, and this is moving away from that plane. This is sticking out of the plane. So this is a way that people write is Sb. This is on the plane. This is out of the plane. This is moving away from the plane. And you should now visualize this forms some triangle that is perpendicular to the axial axis. That's how they do. And then they ask, what's the hybridization? You got 5, right? So Sp3D. That makes it 5, right? That's it. Selenium. Okay. Selenium dichloride. Selenium means 6. Okay, selenium is 6. And okay, the chlorine is, I need 2 of them. So that means 2 electrons are being consumed to form the bonding with the chlorine. And you have 4 electrons left with. They're going to pair them up to 2 lone pairs. So that's a 2 lone pairs, 2 bonds. That make it 4. 4 means Eg4 means tetrahedral. All right, that's easy. So then I'm going to draw a tetrahedral, selenium in the center, and that's how tetrahedrals are being drawn. That's 4 connections, and then I'm going to put chlorine, which whatever is your choice, but people probably put chlorine there. And these 2 bulky lone pairs. Right? Bonds are being shared between atoms, so it's kind of narrowly confined, whereas the lone pairs are just sticking to the one of the central atom. Then it's a floppy electron exercising higher repulsion than the bonded paired electrons. Okay? So it's actually, do you guys remember what's the angle for this? That's a 109. You remember that? But if you have these 2, they are floppy, so this boundary is being squeezed. So it's like a 108 or something like that. It's a smaller angle than the bond angle for methane, right? CH bond angle for methane is 109.5 or something. This is a squeezed. So to finish that up, okay, so this is a tetrahedral electron group geometry, and I guess a bent. That's a shape. Hybridization. That's a 4, right? So that means SP0. Okay, and that's it. That's the one. So you'll get to see the answers here. That's also additional information, but pretty much I can solve this problem within this space. So do the practice always. The way that I like is, this is I do the very shortcut way. I know the chlorine, fluorine, whatever in the halogen, they only demand 1 electron. So this is a case that where the exercise is very easy. You can just take 5 electrons, stealing the 5 electrons from the center, 2 electrons from the center. This chlorine with the central bonding is done, and then you count how many leftover electron located at the center, and then you start to counting that. And that's the way that we do it. I mean, these are the, so that's why I told you that, even going back to the previous one, this is an easy experiment, easy problem. That's the one is essentially you have to deal with oxygen, whether forming a single bond or a double bond, to minimize the local the formal charges, and then you start to count the electron group geometries, count the number of electron groups to consider geometry of electrons.